All right, hey everybody, Mr. Fortin here, filming this video going through the area and volume multiple choice quiz, which we had right before finals, and you have more multiple choice questions coming next week during finals. So I figured maybe you'd want to watch this video and get to the bottom of maybe some of the multiple choice questions that kind of were a little harder for you or you weren't sure how to do when you took your group quiz the week before finals. Okay, so we're looking at this first one here. A square is inscribed in a circle with a radius of 8. What's the area of the square? So for this one here, I was hoping you'd think about the fact that any regular polygon, okay, and a square would be a regular polygon, it's a regular foregon here. We talked about this. Every regular polygon has a radius. Okay, has a radius. Not the apothem, okay, but the radius here. And the radius here is 8. Okay, so you don't even really need to think about the inscribed, the fact that it's inscribed in a circle, but you could draw that if you wanted to. Okay, right? The radius of that polygon is going to be the same as the circle that would be circumscribed about that square. Okay, but the key thing is here, this is 8. I know lots about squares. I know that the radius, for instance, was going to bisect, right? The diagonals of a square bisect the angles, okay? Because a square is also a rhombus, right? It has 4 congruent sides. Okay, so if this is 8, and I do this down here, well, this is also 8. Okay, if I do actually all these radii, okay, they'd all be 8, 8, 8, 8, 8, 8. And then these would have to be a 90-degree central angle. Okay, check it out here, 90-degree central angle. So what do I have here? I have an isosceles right triangle. Okay, an isosceles right triangle. So if I have 2 legs of an isosceles right triangle, that's 8 and 8, I know that the hypotenuse of this isosceles right triangle has to be 8 root 2. Okay, that's a quick way of going about it. Okay, but I know the diagonal also bisects the angles. So instead of 90 degrees, because it's a square, this is 45 here. This is 45 here. So we have 45, 45, 90 triangles. Okay, so if I'm going to get the area of this, area for a square is that side length squared. Okay, I'm going to do 8 root 2, and then I'm going to square it. Okay, 8 squared is 64. Root 2 squared is 2. So 64 times 2 is 128. And that is my answer. Okay, looking at the second one here, we have ourselves a trapezoid. Now this is a trapezoid because that's a quadrilateral where I have a pair of opposite sides that are parallel. And I know with a trapezoid here, look, I'm going to look at triangle AOB and triangle DOC. This is AOB right here. This is DOC right here. And because they have parallel lines, I know that alternate interior angles are congruent. So in this problem here, you're thinking, what have I studied about this with the trapezoids? Well, this top, bottom, and bottom triangle, top triangle, bottom triangle, are going to be similar by AA. So triangle AOB is similar to triangle DOC by the AA similarity postulate. Okay, I have the vertical angles, I have alternate interior angles, right? It may take a minute or two for you to figure that out if you didn't recall it from our practice in section 9.6. Okay, but they are similar by AA. So I know that I have here side lengths AB and DC, which I have, DC and AB, they correspond to one another. Okay, so my sort of A to B scale factor, linear scale factor here, right? That's what we've been representing the linear scale factor recently. My A to B scale factor here is 6 over 18. Okay, and how can I simplify 6 over 18? Well, that's 1 over 3. Okay, and because I have similar figures, the areas of similar figures, remember, areas are a 2-dimensional calculation, okay? So my heights, for instance, would be 1/3, this height here would be 1/3 of this height here, okay? So my area grows by the square, okay, of the scale factor, the linear scale factor, okay? So what I simply do is I just square it on up, okay? And 1 over 3 squared, okay, is going to be the same thing as 1 over 9. So this guy here, I can chop this up and put it inside and multiply it by 9. That's what it would take to fill up this area right here. Okay, and what I got my answer. Okay, the square, the area ratio of similar figures is simply the square of the linear scale factor. Number 3 here, okay, circle with a radius of 5 units. Well, I know that the radius of a circle is the area of a circle is pi r squared, so that's going to be simply pi 5 squared, okay? 5 squared is 25, so this is going to be 25 pi, which is going to be about, you do it in your calculator real quick. I think it was about 81 or 78 or so, okay, if you put it through. Square with the side length 9, well, that's easy. That's 81. Trapezoid with bases of 8 and 10 and height of 9, well, I'm going to do 1/2 B1 is 8 plus B2 is 10, okay, and height is 9. So 1/2 B1 plus B2 times H, right? Formula dump, right? That's a big thing in the area and volume unit that we've had here, okay? 18 divided by 2 is 9. 9 times 9 is 81, okay? So I know maybe it's the circle, but it's also the rhombus, okay? So I also have the rhombus here, right? I got a 8-unit height. More importantly, I have a 9-unit length here, okay? So a rhombus, I drew this terribly, 9, 9, 9, 9, okay, right? A rhombus, I know I have all sides are equal. A rhombus is also a parallelogram, right? It's also a parallelogram. That's a symbol for parallelogram here, okay? And the reason is because I have two pairs of opposite sides that are congruent to one another, okay? And I know if I have a quadrilateral with two pairs of opposite sides that are congruent, I have a theorem that says, well, that quadrilateral has to be a parallelogram, okay? So I can actually use this side length here of 9, and I can use the height of 8 to use the parallelogram formula, area equals base times height, okay, to get its area, okay? So my base length, okay, is 9, and my height is 8. My area here is 72. Okay, so even though we do have a dedicated formula for rhombuses for their area, 1/2 diagonal 1 times diagonal 2, okay, that's one way to get the rhombus area. I can also still just fall back on the area of a parallelogram formula, okay? Base times by height, okay? And I drew this rhombus, doesn't really look like a rhombus there, okay? Number 4 we're going through. So number 4 here, I got to get the area. So the key for this one, the shaded region here, is that this right here, my friends, okay? Maybe I'll do it in purple here. This right here, this is a sector AOB, okay? So if I get the area of the sector AOB, area of the sector, okay, I simply need to subtract, right? That's this whole thing here. To get the shaded region, I'd have to just subtract the triangle minus the area of triangle AOB, okay? And that's going to be the shaded region, okay? Right? The sector would be this whole thing. I just want to get part of the sector. Well, I want to take away that triangle there, okay? So here's how I do this. This sector here has a 90-degree central angle. They gave that to you here, okay? Remember, how many degrees are there in a circle? Okay, well, there's 360. So this whole circle is 360 degrees. This sector fills up 90 degrees of that. So that means 90 over 360, that's 1/4 of the whole circle would be this sector right here. And what do I know about a circle? Well, a circle has the formula pi r squared as its area, okay? 1/4 of pi r squared would be sector AB's area, okay, right here, okay? So what do I need to do? I just need to subtract this triangle here from that, okay? And that's gonna be, an area of a triangle is 1/2 base, okay, right? Radii of a circle are all congruent, so my base is 6, and my height is 6 because I have a 90-degree angle right there, okay? Now I just mathematically solve this right here. 6 squared is 36, and remember 90 over 360 is 1/4. 1/4 times 36 is 9, so I have 9 pi, and I have 6 times 1/2 would be 3, and 3 times 6 is 18, so minus 18. Okay, so I have my answer there. This one here, number 5, how many cubes with edge length 1 unit would fit in a cube with an edge of length 3 unit, okay? All cubes are similar to one another. That'd be true of any platonic solid, right? It would be similar to any other of that type of platonic solid, okay? Any octahedron, okay, would be similar to any other octahedron, okay? Because they have identical properties, they just have different linear scale factors, okay? So what I know about this linear scale factor is a 1 to 3, right? A to B, linear scale factor is 1 to 3. My volume scale factor, remember, volume is 3 dimensions, 1. Height is 1, depth is 1, width is 1. Width is 3, depth is 3, height is 3, okay? Volume has 3 dimensions, okay? So what I need to do is I need to take my linear scale factor and then cube it to get the volume ratio, okay? So what I'm gonna do is 1 cubed over 3 cubed, and 3 cubed is 27. Okay, is 27. So there it is, right? If here I could fit one of these cubes, I can fit it 27 times that. Okay, just by tripling the side lengths, all of the side lengths, I have made the volume 27 times bigger, which is a pretty incredible idea to think about. All right, a sphere has an area of 16 pi. Almost done with this video. Almost done going through all these problems here. 16 pi, what's the volume? So here, area, right? That just means the surface area. Okay, we're talking about a solid. We say area, we mean just area of the surface, the outside, the crust. Okay, and with a sphere, we don't have any bases. Okay, so we don't have any lateral area, we don't have any base area. We just have the total surface area. Okay, so that's what we need to find. So what do we know about total surface area? Well, it's 16 pi. It's given to us. Okay, but we know it's equivalent to the formula, right? That we can get the radius here, right? Because we have 4 pi r squared as the formula for the surface area of a sphere, right? That's my formula, okay? 4 times the great circle of the sphere, okay? As we talked about last Friday, okay? And you know what? I can solve for this now, okay? What can I do? Well, first of all, I can divide both sides by 4 pi, okay? So I can isolate the r squared part, okay? I can figure out r, right? If I know r, I can get its volume. Remember, volume equals 4 over 3 pi r cubed. We'll get back to that later. Okay? So let's get back to this one now. We can solve for r, okay? Solve for r here. Pi divided by pi, okay, well, just cancels out. Pi divided by pi cancels out. 4 divided by 4 cancels out. 16 divided by 4 is 4, okay, and I'm going to bring down my r squared. What can I do to both sides right now to isolate r? Well, I can take a square root, and I'm just going to take the positive square root of 4, which is 2, because, again, radii need to be positive. They can't be negative length, okay? R is 2 right here, so what can I do? I need to get my volume, okay, and here's my volume formula right here. Okay, so I should just go ahead and pluggy on in to that volume formula. 4 over 3 pi 2 cubed, okay? And because all I need is a radius. That's all I need to describe how large the volume is of a sphere, or also how much surface area there'd be too, okay? But I didn't know the surface area. I didn't know the radius. Now I have it. I get my volume, okay? 2 cubed is 8, okay, right? But the order of operations, PEMDAS, do your exponent here first, okay? 4 over 3 pi times by 8. And pi, you know, is an irrational number. We'll kind of like leave it by itself here. But I can multiply this rational number, 8, times by 4 over 3. Okay? And the way that works is this is the same thing as 8 over 1. So I can do 4 times 8, which is 32. And it's all over 3. And then times by pi. Okay? And that's my answer. 32 over 3 pi. Okay? Or 32 pi over 3. Same thing. All right. We get to the last 2 problems here. The square-based pyramid has a slant height of 10. Let's go ahead and draw that in. Slant height here is 10, and base edge is 10 units. What is the height of the pyramid? Well, the height of the pyramid would go down like this. Boom, right here. This is H. Okay, H right there. Okay, I know this is 10, I know this is 10. So why are they giving me all that information? Well, I have 2 attributes of a right triangle that's right here, okay? My slant height is 10, and you know what? Since this is a square-based pyramid, this is the apothem, okay? This is the apothem here. This is half, right? The side length here. The whole side length here is 10, so this is 5, okay? And if I have this here, I have 2 sides of a right triangle, okay, because the height also, again, heights are altitudes, right? We know we have a right angle there. The right angle here, that was on the face of this. I didn't actually need to draw that. I meant to emphasize this is the slant height, so it would have a right angle at this base edge length here. It doesn't really matter for this problem, okay? So what I have here is a right angle running sort of in the inside of this pyramid here, and I want to get H, okay? And if this is 5, this is 10, okay? There's only one kind of triangle that has a 1-to-2 ratio between one of the legs and one of the hypotenuse, and that is a 30, 60, 90 triangle, okay? So this is 5, this is 10. This has to be 5 root 3, okay? But you could also have just done it, like in case you if you forget that 1-to-2 ratio leg to hypotenuse, the other one's 5 root 3, you could just use Pythagorean theorem. But for the sake of this video, making this kind of a bit more short, okay, we'll just use the shortcut. 5 root 3 is the answer. Let me know if you have questions on that. Finally, find the total surface area of a cylinder with a radius of 4, okay, and a height of 6. Here, when in doubt, sketch it out. That's going to be an important thing to your success in math classes, especially in geometry here, okay? Total surface area, okay? What do I know about total surface area of a cylinder? Well, I have 2 bases, and I have to worry about my lateral area, okay? Total surface area means everything, every surface, whether it's a curved surface like this one or like the circular surfaces here, okay? So my 2b, that's pretty easy because I have here, right? Each b is a circle, right? Pi r squared, okay? And I have 2 of them, so I'll have 2 pi r squared here. And then my lateral area, remember that was a rectangle, okay? If I cut along here, I'd have a side length of 6, and I unfurl it, okay? Spread it on out, okay? Well, I cut it here, well, and I unfurl it out here. Well, that would actually match up. My unfurling would match up with the circumference of that base right here, 6 times by 2 pi r, okay? Remember the lateral area here is simply 2 pi RH. Okay, there's your formula for the surface area of a cylinder. Okay, using formulas, kind of reasoning through it, maybe drawing it out. We just need to plug in because we have our radius of 4. Okay, so I have 2 pi times by 4 squared. Okay, and I'm going to use that again in the lateral surface area. 2 pi times by my radius here is 4, and my height here is 6. And I just need to multiply it on through. Okay, again, my numbers, so I do my exponents here first. This is 8, and 8 times 2, I can just ignore pi for now. 8 times 2 is 16. Leave the pi with us. Okay, so there's the total base area. Lateral area, 24, right? 4 times 6 is 24, and then I got the 2. 24 times 2 would be 48. What did I do wrong here? I did something wrong here. 48 plus 16, sorry, you got to get to 80 somehow. What did I do wrong? Oh, 16 times 2 is 32. Oops. Oopsie daisies. Okay, so one of these circles area is 16 pi, so 2 of them would be 32 pi. Okay, this here, okay, so this is 32 pi right here. And then this here is going to be 24 times 2 is 48. And they'll leave the pi on there. And 32 pi plus 48 pi, well, that equals 80 pi. And there is my final answer, okay? So we came at you kind of with a decent amount. It only really gave you about 25 minutes to do this, but hopefully you worked through it with your groups pretty successfully. Your final exam, okay, is going to have about 42 questions, okay? You got about 2 hours to do it, though. So anyways, noticing an inappropriate drawing in the back of this classroom, so that's kind of distracting me. Anyways, message me if you have any questions about this. You definitely have some area and volume problems on the final exam. So thank you for watching, and hopefully it helped you out thinking through some of these. And you can be more successful or just as successful in the future if you did quite well. Let me know if you have any questions. Thanks for watching. Bye.